Okay, guys. Okay, guys. So let's look at this question from one of the HSC questions. So what they're saying is that Emily placed $1,500 into an account for his son on the day of his birth. Okay, let that be A0 because that's when he was born. Because when do we say someone was 1 year old? Not the day they were born, but 1 year after they were born. That's when we say, oh, he's 1 year old. So when we say you're 18 years old, you've actually lived for 19 years old. Okay? Because as soon as the child is born, you don't say he's 1 year old. You say 0. So A0. So on the day of his birth, $1,500 is placed into account. Okay. And an additional $1,500 every year on his birthday. So A0 is 1,500. And then she's paying at A1, she's adding another $1,500 at every birthday, an additional amount. Now, 6% compound interest is paid annually on that account. So what's the value of the account on our son's 18th birthday? Okay, cool. So what we want to identify is it's very important to identify that this really is A0 that we're starting off with, not A1. Okay, A0 is equal to $1,500, and Emily is only putting that money into the bank. The money is getting compounded because the year hasn't been passed. Now, when we get to A1, right, what happens is, see this 6% compound? It compounds annually. So, 1 second. Yep, thank you. So, see how this compounds annually? As in, after this 1 year has been by, now Emily will get 1.06% of that. Like you multiply that number by this because that's an added 6%. 1,500 times 1.06, right? That's the amount she has now, except it doesn't end there. That's the amount at year 2, except there's an extra $1,500 at the end of each year. So plus $1,500. Easy. Then A2 is equal to, we take this amount, so 1,500 times 1.06 plus 1,500. And then this is the amount at the first year, right? This gets multiplied by 1.06 because that was the interest, plus there's another $1,500. Okay, cool. So when this gets multiplied in, we can multiply it in, and we will get 1,500 times 1.06 squared, because see how when you take this and multiply it here, this is one term and this is the other because it's separated by the addition. When you multiply it here, it becomes squared, right, plus 1,500 times 1.06 normally, and there's an additional 1,500 at the end. Okay, now we can factorize this out. We can take the 1,500, which is common out, and we'll get, let's start it from the reverse, right? Because it makes it easier down the line. Let's factorize it from here, treating this as our first term. So it's 1 plus 1.06 plus 1.06 squared. Okay, that's what we get. And then this pattern continues until the son's 18th birthday. A18. Okay, now until the son's 18th birthday, and the final, okay, so what was that on her son's 18th birthday? So they want it as soon as on the 18th birthday. So I'm supposing that when the son turns 18, she would add another $1,500. Yes, she would. My bad, yeah. She would add a $1,500. Okay. So then on her son's 18th birthday, we want to notice this one trend. At this point, we see that A2 is equal to this 1,500 times 1.06 to the second power. That's the most. So this pattern is going to continue, but except these numbers are going to change. And this is a GP. So 1,500, 1 plus 1.06 plus 1.06 squared plus ... plus 1.06, 18. Okay. Nice. 18. Because it goes on for 18 years. So we can say this number is equal to that number. Okay. Now, are we done? No. What we need to realize is that this is an AP. My bad, this is a GP. Okay, and we want to first prove that it's in GP. So this is a GP, and to prove, let 1 equals T1, 1.06 squared equals T2, and 1.06 cubed equals T3. T2 over T1 is equal to T3 over T2, which is equal to 1.06. Therefore, R is equal to 1.06. This is a GP. Nice. So now that we've proved it's in GP, we can continue with our normal steps. What is that? Well, we can find the sum of this by, because R is greater than 1, we can use this formula. Sum is equal to A Rn minus 1 over R minus 1. Okay, nice. So the sum, or the first, how many terms? That's the question. Is it going to be 18 terms? No. And let me give you a formula to finding out how many terms. To find out terms, you got to take the last one plus the power of the last one plus the power of the first one, and you want to subtract that. 18 minus 1, right? Plus 1. That's what you want to do, right? And yeah, but then not really, because this is 1.06. Remember this 1, right? How did this 1 come about? It's 1.06 to the power 0. So it's not that, but it's 18 minus 0 plus 1, which is equal to 19. And there's 19 terms. And think about it logically. How many terms when you start from 0? Count from 0 to 18, including 0. You'll get 19 terms. So then it's S19 is equal to, what's our A? In our case, A is 1. What's our R? Our common difference is 1.06 raised to the what? 19 minus 1 over 1.06 minus 1. Okay, so now our value at our 18th birthday is equal to just 1500 multiplied by 1 by 1.06 to the power 19 minus 1 over 1.06 minus 1. Okay, and when we do punch that into a calculator, I'm doing it right now, don't worry guys, over 1.06 minus 1, we get 50,639.99 to 2 dp, which is equal to $50,640. Nearest whole number. Okay, and well, yeah, that's the value of the account on his 18th birthday. Okay, nice. And now, technically, what was the interest that was paid? Well, think about it. If there were 19 years that you paid this account for, what's 19 times 1500? 19 times 1500 is equal to 28,500. So the interest is just this value minus this value. So 50,640 minus 28,300. So the interest is equal to $22,000 and 340. Okay, easy. And that's how you solve this question.